Welcome to another video. This time we're going to be going through subtracting integers. Last week we looked at a video of adding integers, and so the natural extension of that would then be subtracting. You'll find a lot of similarities in this video. So fundamentally you should have a good understanding of subtracting whole numbers, so the positive numbers and zero. Now we're just going to be delving into subtracting numbers where we also include the opposites or the negatives. So ultimately what we're going to cover today is simplifying expressions with integers, evaluating variable expressions with integers, translating word phrases to algebraic expressions, and then subtracting integers in different applications. So first of all, we need to look at what is the subtraction property. And so all this is saying is that when we're simplifying expressions with integers, we can actually turn this into basically the same problem as we had in our last video on adding integers. So instead of a minus b, we can have a plus negative b. And this is the exact same problem that we worked through last week. And so this should, if you watch that video first, this should be super easy, but we'll go through a few examples here. So just to prove things, let's simplify 13 minus 8. And so 13 minus 8, let's go a. 13 minus 8 equals 5. And then 13 plus negative 8. Well, 13 plus negative 8. We don't really need to do any swapping as we did in the last video. We can just do 13 minus 8 again. So remember, a plus and a minus is just a minus. And so 13 plus negative 8 is the same thing as 13 minus 8, so we also get 5. So as an extension of that then, if we have negative 17 minus 9, the best way I can tell you how to approach this is to go, all right, why don't I turn this into two positives? So if instead of writing negative 17 minus 9, why don't we turn this into 17 plus 9? 17 plus 9 is 25, and since we've actually got the opposite of 17 plus 9, we've got negative 17 minus 9, that means this would be negative 25. So just to reiterate that there, if we have some expression here, and we find it hard to work with our negatives, we can just flip the signs of both the numbers, solve, then we'll just flip the sum as well. So then finally, negative 17 plus negative 9 is going to be the same thing. And so if we do negative 17 plus negative 9, we could then flip that again, have the two positives, which will equal 25. Therefore, this should equal negative 25. So a couple more examples. Let's go through example A. So 9 minus negative 15. So importantly, from the last video, you would have seen that if we have a negative and a negative, or a positive and a positive, it just becomes a plus. So what you could think of this is, if I put another bracket around there, from our last video, we could see that this would be negative 15, and this would be the opposite of that, which would mean that it's a positive. So this could then transform into 9 plus 15. Which should be super simple. If you need help with that, go back and watch our addition video, which should have been in section 1. So we will get 24. So then naturally, this is already taken care of. It's the same value that we'll get. They're just two ways of expressing the same thing. So then secondly, let's go with B. So negative 7 subtract negative 4. The two subtractions, or the two negative signs, or the opposite of the negative, whichever way you want to say it, that becomes a plus. And so we get negative 7 still, that's fine, but then it'll be plus 4. Now, if you can't work this out, you could then flip the signs, get 7 minus 4, so that negative has then become a positive. This positive has then become a negative. 7 minus 4 should be a lot easier, so that's 3. Because we flipped that, the actual answer will be the opposite of 3, so it'll be negative 3. So negative 7 plus 4 will be negative 3. Now onto a little bit of a harder one. So we've got negative 74, subtract negative 58. So the first thing I'd do would be I would write it down again. I always find it helps me personally if I just write down verbatim the exact same expression. It's always good to just write something down. Now, working on this, I would look at my signs and I would see that I've got the opposite of a negative number, which would be a positive. So I could turn this into negative 74 plus 58. From here, I find it a little bit hard to work in the negatives. So what I would do would be I'd flip the signs. So this could be 74, so positive 74. And instead of positive 58 or plus 58, it would be subtract 58. Now, this I would then move down here and put it into columns. And then I can work on it as we did previously. So 4 minus 8, we can't do that. So we have to borrow from the tens place. 14 minus 8 is 6, and then 6 minus 5 is 1. So we get 16 for 74 minus 58. Therefore, we actually have the opposite of that. So we've got negative 74 plus 58. So this would equal negative 16. So if we flip it and it becomes the opposite of the actual expression, we would then need to flip the result or the sum to retain the actual value of the original expression. So now 7 minus negative 4 minus 3 minus 9. So this is just moving into some normal order of operations kind of problems. So if you need a refresher, we use BOMDAS or BODMAS or PEMDAS. There's plenty of different ways to say it, but essentially what they mean is we deal with parentheses first, or brackets, or absolute values as we saw in the last video. Then we can go on to our indices or our exponents, and then we can do multiplication or division from left to right, whichever comes first, and then addition and subtraction left to right as well. And so here I can see that I've got brackets, so I want to simplify that first. So you should be able to do this in your head eventually, but what I would do would be I would flip the brackets. So I would flip the stuff inside the brackets. So it would be 4 plus 3, which would equal 7. Now I would actually want the opposite of that. So you could almost think of it as the opposite of 4 plus 3. Remember, this signifies an opposite. So that would have to be negative 7. Therefore, I could substitute negative 7 into the brackets there. Now, looking from left to right, there's nothing to actually simplify in the brackets. What I could do, though, is simplify the 7 minus negative 7. And I know that the opposite of negative 7 would be positive 7. So I'd end up with 7 plus 7 minus 9. And then here I would work from left to right. So 7 plus 7 would be 14 minus 9. And then 14 minus 9 would be 5. So now adding in some multiplication there. So we really need to start thinking about our order of operations. So 3 times 7 minus 4 times 7 minus 5 times 8. Now from here, I would just expand all of these. So I would do each multiplication. I won't do those one step at a time. I'll do them all at once, but we've got to make sure we retain the signs in between those multiplications. So what we would have here would be 3 times 7, which is 21, minus 4 times 7, which is 28, minus 5 times 8, which is 40. If you have any trouble with multiplication, we've got a multiplication video for whole numbers also, and our next video should be multiplication and division with integers, so including those negatives. So now I can see that this would become tricky. I'm going to go further and further to the left on a number line, so I'm going to go negative because 21 minus 28 has to be less than 0, and then subtracting 40 off that would then leave me further in the negatives. So what I would do would be I would flip all of the signs here, and so I could say that this is the opposite of negative 21 plus 28 plus 40. And then I could rearrange this into 40 plus 28 minus 21. Remembering that it's commutative. It doesn't matter what order these are in, as long as they're all just additions or subtractions. I can move them around as I will. Now this would then be 40 plus 28 is 68 minus 21. And 68 minus 21 would be 47. So because I've flipped all of that, I would then have to flip that sum. And so I could say that this would be negative 47. So now onto evaluating some expressions where we've got variables. So evaluate x minus 4 when x equals 3 and then x equals negative 6. So just as a refresher, when we're evaluating, what we're doing is we're plugging in some value for x and then we're going to find some result. And so for a, we know that x equals 3 in the equation x minus 4. So I would first write a bracket where the x is, and I just fill in the rest of the equation normally, or the expression normally. And now I can see that for a, x equals 3. So 3 minus 4. We could flip the signs to make it easy, and we get negative 3 plus 4. If I rearrange that, I would then get 4 minus 3. And 4 minus 3 equals 1. Therefore, 3 minus 4, which is the opposite of 4 minus 3, is equal to negative 1. So for the first one, for x minus 4 when x equals 3, it equals negative 1. Now for b, we would then do the exact same setup, but in this example we're putting in negative 6. So negative 6 minus 4, I would then flip the signs. I would say, all right, can we make that 6 plus 4, which equals 10? Therefore, negative 6 minus 4 must equal the opposite of 10, which would be negative 10. Evaluate 20 minus z when z equals 12 and then z equals negative 12. So for a, same process as last time. Hopefully you're having a go at these as we go. So 20 minus and then brackets where the variable is, and I plug in 12. And so the brackets really help to reduce sign errors. And so 20 minus 12, I can do that quite simply. That would just be 8. For b though, we've got to be careful, and this is where it comes in handy. So 20 minus and then brackets, and then we've got negative 12. Now this means the opposite, and this is negative 12. So therefore the opposite of negative 12 would be positive 12. So this would then be 20 plus 12, which would equal 32. So two very different answers based on the signs. Translate and simplify. The difference of 13 and negative 21. So to translate means we want to find our keywords and turn this into mathematical notation. So I can see the difference. Difference is another way of expressing subtraction. So for a, we could express this as 13 minus negative 21. So you've really got to be careful. So the difference implies subtraction, but that doesn't mean that this would just become 21. You need to keep that negative in there. This would then be the opposite of negative 21, which would be positive 21. So 13 plus 21, which would then equal 34. For b, we're looking for our keyword again. This time it's quite easy, so we see subtract. Now it says subtract 24 from, which means that negative 19 will come first and we'll be subtracting from it. So negative 19 minus 24. I would then turn this into 19 plus 24. And so I would get 43. Therefore, negative 19 minus 24 has to be the opposite of 43, which would be negative 43. So you should be getting the gist of the fact that we can mainly turn all of our negatives and our opposites into whole numbers, rearrange expressions and equations, and solve them just like we did in our subtraction practice video. So now, since it's been a while since we've had these steps on a video, we really need to internalize how to go about solving application problems. So the steps become ingrained over time and they will be more fluid, but if you're having trouble, write these down and then try and follow them and just take it step by step, do one thing at a time, and you should end up with the right answer. So the steps are to identify what you're asked to find, write a phrase that gives the information to find it, then translate that phrase to an expression, simplify the expression, and then answer the question with a complete sentence, because remember that we want complete sentences because we've got worded questions when we're doing application problems, so we expect worded answers. In the morning, the temperature in Melbourne, Victoria was 11 degrees Celsius. By mid-afternoon, the temperature had dropped to negative 9 degrees Celsius. What was the difference between the morning and the afternoon temperatures? So here we can see a keyword which would be the difference. So remember, difference indicates subtraction. We also want to find the difference between the morning and the afternoon temperatures. So we've got 11 degrees Celsius and -9 degrees Celsius. And so that's basically everything that we need from this sentence. So the way that we could turn this into a phrase would be, since we're finding the difference between 11 degrees Celsius and -9 degrees Celsius, we could then subtract -9 from 11. So the way that we could write this would be 11 minus -9. Now this should seem quite easy, hopefully, after the last few examples. So 11 minus -9 turns into 11 plus 9, which equals 20. Therefore, there is a 20 degrees Celsius difference between the morning and afternoon temperatures in Melbourne. And so you can see here a worded answer for this that would be sufficient would be the difference in temperature was 20 degrees Celsius. Of course, if you want to provide some context, like in Melbourne, Victoria, that's also perfectly fine. It's better to be on the safe side, depends on who's marking. So adding that may be beneficial. Dinesh hiked from Mount Whitney, the highest point in California, to Death Valley, the lowest point. The elevation of Mount Whitney is 14,497 feet above sea level, and the elevation of Death Valley is 282 feet below sea level. What is the difference in elevation between Mount Whitney and Death Valley? So hopefully you pause the video and have a go before I go through the answer. But my first thought is, what am I looking for? What do I need to identify that I have to actually do? And so I see I'm looking for the difference in elevation. So I have two elevations. I have Mount Whitney's elevation, which is 14,497 feet above sea level, and then I have 282 feet below sea level. So if you were to write 14,497 feet, subtract 282 feet, that would be incorrect. Remember, 282 feet below sea level would be below zero, which would be a negative. So to convert this, you would say 14,497 subtract, and then because we're going below sea level, we would go -282 feet. And so you'll find that this ends up being 14,497 plus, remember the opposite of a negative number is a positive number, so we have a plus 282. This means that this number is going to be larger than the elevation of Mount Whitney, which makes sense because we're going below sea level, and Mount Whitney's elevation is based from sea level, so there's actually a larger difference than the altitude of Mount Whitney. So here we can just set this up in columns, so this should be good practice for you from addition. And so we just need to make sure that our place value is lining up correctly. So 7 plus 2 is 9, 9 plus 8 is 17, carry the 1 over. Then we go 1 plus 4 is 5 plus 2 is 7. And then there's nothing else to add, so we can just bring these down. So we end up with 14,279. Sorry, that should be a 7. 14,779. So to answer the question, you could say something similar to, the difference in elevation between Mount Whitney and Death Valley is 14,779 feet. So here, the difference in elevation between Mount Whitney and Death Valley is 14,779 feet. So I think I said that exact same thing a second ago, so that's probably a good sentence to put at the end. Leslie has $25 in her bank account and spends $8. A, what is the balance in her account after she spends the money? B, she spends another $20. What is the new balance? And then C, Leslie's friend told her she's transferred her $10. What is the balance in Leslie's bank account now? So with these multi-part questions, it's important to hone in on each, or the first section, and really try and get that right, because a lot of the time they will follow through to the next question or the next sub-question. So getting the first one right and being really careful is definitely important, and each one is generally going to follow along. So what is the balance in her account after she spends money? So remember, if she starts with $25 and then she spends $8, she's really subtracting $8 from that account. So for A, we could set that up as $25 minus $8. Now 25 minus 8 will be $17. So if I was going to answer that, I would say the balance in her account after she spends the $8 is $17. Now for B, she spends another $20. What is the new balance? Well, remember our old balance was 25 initially, but then it became 17. So it's important we got that right so that we have a base for our new question to build from. And so we actually start with 17 and we're subtracting $20. So you'll see that 17 is a smaller number than 20. So what we would do would be we would flip the signs to make this nice and easy. And so this would then become temporarily negative $17 plus $20. Now we could then flip the order of those. Remember that it's commutative, and we could turn it into $20 minus $17. Now hopefully you can see this would be $3. Therefore, our original question was the opposite of that. So therefore, this would equal negative $3. So $17, she spent $20, therefore she's overdrawn her account, which means gone below zero by $3. And then finally for part C, Leslie's friend has transferred her $10. What is the balance in Leslie's bank account now? So what does it mean if she's been transferred $10? That means that someone has put more money in her account. So we could say that it's added to her account. So we would set this up as -$3 plus the $10 that her friend has added in. And I would reorder this to $10 minus $3, which would then equal $7. And so Leslie's new bank account balance would be $7 after her friend transferred her $10. So she's gone from $25, she's spent $8 and then spent another $20. Then her friend has added $10, and so she's ended up with $7. So A, the balance is $17, B, the new balance is -$3, and then C, the balance is now $7. So that brings us to the end of our subtracting integers lecture. And so there's not too many practice questions here, but there's just enough. It's going to be about turning these integer problems where there's negatives involved and finding a way to reframe them in the context of whole numbers. And so that becomes super important when you're doing hand calculations. But if you do have access to a calculator and you're allowed to use it in your upcoming exams or tests or anything, as long as you have these foundational skills, it's fine to use the tools available to make your life easier. So the next one will be about multiplication and division. So it'll be good to see you there.